Okay, so in this video, I'm just going to wrap up part 3 or page 3 of the notes packet that we had, the last page of the notes packet that we had in class today. Focus again on probability and counting, and we're going to start to look at some more in-depth examples. Key thing to remember is kind of what I see written up here, the probability of our event. What's the probability of our event happening? How do we calculate it? We count up the number of ways that our event can occur, and we divide it by the number of ways that all events can occur. Sometimes I call that denominator the universe. It's the sample space, but again, it's just how many ways could any event occur? That's the key. So let's go back and start working through these problems. And a lot of them, one of the smart things to do is almost treat it like, hey, this is a job for me. And pretend, how would I actually do this job? So the first problem says you have 13 cards that are dealt from a well-shuffled standard deck. That's 52 cards, as we know from before. What's the probability that the 13 cards you pick are all red? That's the first. So here's what we need to do. First things first, what are all the events that could happen? What's our universe? Well, our universe is simply taking 13 cards from 52. Order does not matter. So our universe, the number of ways that our universe can be represented is C5213. We're going to pull 13 cards from a deck of 52. I also know that that's going to be the denominator of my answer. We always divide the number of our events by the number of events in the universe, 5213, C5213. All right. Now, here's what we need to do. How do I go ahead and build a selection of 13 cards that are all red? Well, if I physically had to do that, the first thing I'd do is I'd look at my deck of cards and I would find all the cards that are red. There are 26 red cards. Once I found my 26 red cards, what's my next task? I'd just go ahead and pick 13 red out of those 26. So how many ways can I pull 13 red cards? It's a C from how many red cards? 26, comma, how many do I need to pull? 13. That's the number of ways I can get the 13 red cards. Number of our ways divided by total number of ways. There is our answer for the first problem. C, 2613 over C, 5213. The second problem, we'll just talk on briefly. There are 12 face cards. So in this problem, what I would actually have to do is I'd need to find out, can I pull 13 face cards? Well, the answer is no. How come? There aren't enough face cards out there. There's only 12. I can't pull 13 face cards when there's only 12 of them that exist. The probability of this second problem is simply 0. Now the third problem gets pretty interesting. It says at least 11 red cards. Well, what would qualify then? 11, 12, or 13. So I'm going to look at each of those individually. I already answered the 13. I'll just kind of mark it up here. Here's my 13. It's C 2613 over C 5213. I'm just going to add the individual probabilities because 11, 12, or 13. If I get 11 cards, there's no way I have 12 or 13 reds. If I have 12 reds, no way I have that. They're all different from each other. So I can simply add these different probabilities. Let's talk about 12. Well, again, C 5213. Right? The job is to do what in this case? Pick 12 red cards. Well, what do I need to do? Where am I going to get the red cards from? I'm going to get it from the pool of 26. So I'm going to have a C 26, comma 12 this time because I'm pulling 12 red. Is my job done? Have I gotten 13 cards? No, I need to get one black. Where do I go to get the black cards? I go find where all the black cards are. There are 26 black cards. So what do? C 26, comma 1. So here we go. C 2612 is how many ways I can grab 12 red cards. C 26.1 is the number of ways in which I can grab one black card. Multiply them together. There's my second piece. And hopefully you'll see what the third piece is. To do 11, I need to get 11 red. I'm going to grab them from the 26 red. And after I do that, I need to get 2 black from the 26 black. What's it look like? C 26 comma 11 times C 26 comma 2. Notice the 11 and 2 add up to 13. The 12 and 1 added up to 13. And then my denominator goes C 5213. So if I add these 3 phrases that I have together, that gives me the probability of at least 11 red cards. Okay, let's work the next example. 20 television set. 6 are good. 6 are bad. 14 are good. If a sample of 3 sets is chosen, there's my universe, there's my sample space. I'm picking 3 out of 20. Order doesn't matter. Universe is C 20 comma 3. That becomes what? That becomes my denominator. Sorry, just got to roll up. All right, what's the job? The job says, what's the likelihood, what's the probability that the sample contains all defective sets? I need to bring back 3 defective sets. How many defective sets are there? There's 6. So to do it, what do I do? If someone said, hey, your job is to go get the 3 defective sets for me, I'm going to go look, I'm going to find where the 6 defective sets are, and I'm going to grab 3 of them. That is a C 6 comma 3. And there's my answer, C 6 comma 3 over C 20 comma 3. Probability that the sample of 3 are all defective sets. Part B, it wants 2 defective and 1 non-defective or good. Okay. Physically, how do I do that? Well, I grab 2 defective from 6, and then I go grab 1 good one from the 14 good ones. As before, what's my denominator going to be? C 20 comma 3. Now let's go handle my 2 pieces. First task, get the 2 defectives. C 6 comma 2. Second step, grab 1 of the goods from the 14. C 14 comma 1. So multiply C 6 comma 2, whatever that value is, times C 14 comma 1. Take that result and then divide it by C 20 comma 3, and you have your likelihood or your probability. So there's the process. Again, treat it almost like you really have a job. You walk in and you're told, here's what I need you to do. I need you to go grab 11 red cards for me. Go look, go find where all the red cards are. There's 26 of them. Grab 11 of them out of the 26. You're not done with this job. It said they wanted 13 total. So I got 11 red. What do I need to do to finish up? I got to go get 2 black. Where do I get the black cards from? I go find all the black cards that are out there. There's 26 of them. I choose 2 from the 26. So C, 26, 11, 26, 2. There's that example. Just again, think it through. What do I physically have to do if someone told me to go perform this job? Break it into the task, and I think you'll see pretty quickly how to go ahead and structure these problems.